Okay, so we've been talking about sequences. So today we're gonna look at 3 different ways that we can represent a sequence. So we have the sequence here, 3, 6, 9, 12. So the first representation we're gonna look at is just a table. So with the table, we have our input, which is usually the x value, and then we have the output, which is the y value. Okay, so the input is going to be which term it is. So we went over the initial term, that's always the first term. So if we have 1 here, so our first term, that's going to be equal to 3. So then the output is 3. And then the second term is 6. Third term is 9. And then our fourth term is 12. And so when we're looking at this, you can see that on both sides, it's increasing consistently. So to go from 1 to 2, we just add 1. From 2 to 3, we add 1. 3 to 4, we add 1. So that's consistent. We keep adding 1. And then we look over here, and we're not adding 1. Instead, we're going to be adding 3. So 3 plus 3, we get 6. 6 plus 3, we get 9. 9 plus 3, we get 12. Okay, so then on this side, it's consistent by adding 3 each time. So that's the first representation, is being able to make a table. The second representation we're going to look at is looking at a graph. So if we're going to go off the same values that we just wrote in our table. Okay, so we know that the x-axis is always the input, and the y-axis is always the output. Okay, so this is which term it is down here. So I've got first term, second term, third, fourth. And then up here we've got the value of the terms. Okay, so the first term is equal to 3. The second term is equal to 6. The third term is equal to 9. And then our fourth term is equal to 12. So looking at this, the graph that we just made creates a linear line. So linear just means straight. So we've got a straight line that's made from this. So something you can conclude from what we just talked about is that this is an arithmetic sequence, right? Because we're adding 3 over and over again. And the graph that we have is linear. So anytime that you have an arithmetic sequence, your graph is going to be linear. So the first 2 representations we just went over is making a table and a graph. The third representation is a visual pattern. So you can see here that I've got 4 different terms right here. Okay, so we've got the first term, second, third, and fourth. So when we're looking at this visual pattern, we see this first term has 3 squares in it. Okay, and then going to the next term, the second term, you see that there's the original 3 squares right there, but then they added 3 more squares on. 1, 2, 3. Okay, so going from here to here, we added 3 squares. Okay, and then now let's look from going from the second to the third term. So this one we've got 1, 2, 3, 4, 5, 6. So we've got 1, 2, 3, 4, 5, 6. So the green ones, that was what we had in the second term. And then the new ones that were added, we've got 1, 2, 3. So once again, going from the second to third term, we added 3. Okay, and then this continues. So again, going from the third to fourth term, we've got the original ones that were in the third term, and then the 3 squares on the ends that were added on. So now going to the fifth term, you would be able to predict what that next term would look like by just adding 3 more squares on. So we've got 1, 2, 3. So now this is what our fifth term would look like. And this relates back to what we were just looking at right over here with our sequence 3, 6, 9, 12. Because our visual pattern, the first one we had 3, and then 6, 9, and then this one did have 12, the fourth one, right? And so that's the third type of representation when we're talking about a sequence. So we've got a table that you can make, and then you can make a graph, and then you can also create a visual pattern from a sequence.